Welcome to our channel. In about 1 billion years, Earth will become too hot to support oceans, and all life here will vanish. That's why we're already searching for a new home. Our adventurous spirit has led us to explore the most remote corners of our planet, creating paths through dense forests, discovering new species, and establishing safe habitats in the jungle wilderness. In the early 20th century, explorers, equipped only with basic gear, ventured into the frozen, silent realm of Antarctica, where survival required incredible creativity and adaptation. Today, our ambitions extend far beyond Earth. As we gaze at the night sky, we wonder if there's another place we can call home. For a long time, we thought Mars would be our next destination in the cosmos. However, this idea turned out to be a fantasy, an impossible dream. It seemed there was no other place for us until we discovered Titan, a mysterious moon similar to Earth, rekindling our hope for finding a second home. But what does it take to build a colony millions of miles from Earth? Why is colonizing Mars a bad idea? And do we have the technology to send human colonists on a one-way trip to Titan? On Earth, we have terrain to work on, oxygen to breathe, drinking water, comfortable temperatures, and protection from radiation. These conditions are crucial for life, but finding them elsewhere in space is like winning the lottery. Take Mars, for example. Geological records show that Mars once had lakes, a warm climate, and possibly life. However, all that is long gone, and today, Mars is a lifeless desert with an average temperature of -80 degrees Fahrenheit. It's a distant world where radiation is so intense that every step on its surface brings you closer to a dangerous demise. Imagine if we decided to build a colony on Mars. First, a team of colonists would board a space rocket on Earth. After about 7 months, they would be the first humans to set foot on the red planet. Their initial task would be to construct a safe habitat, a sealed environment that maintains the right air pressure, oxygen levels, and temperature. This habitat would need to be large enough for people to live in and equipped with everything necessary for survival, including space for activities like farming. Scientists are studying Mars to find the safest locations rich in minerals, where the first large domes would be built as the foundation of the future settlement. These domes would provide shelter from intense cosmic radiation and dust storms. Excavators would then start digging up soil, and 3D printers would turn it into physical structures. Humanity would build its first housing on an alien world, with buildings extending underground and connected by tunnels. At this point, the colony would no longer face external threats, but it would still rely on a constant supply of water, oxygen, and energy. Life in the colony would be challenging. Biologists would spend most of their time finding ways to enhance vegetation growth, as even slight changes in temperature, pressure, gravity, or humidity could threaten the entire harvest. Eventually, the colony would fully depend on this vegetation. Geologists and other scientists would spend most of their time outside the domes, searching for potential ice deposits. Nothing would go to waste. Water, minerals, sweat, and even urine would be recycled. 3D printers would create spacecraft components and essential tools, as shipments from Earth would take too long. The system would be fragile, with no room for error. Energy production would be crucial. Sandstorms on Mars are frequent. Once sand grains rise into the atmosphere, they create a thick veil that blocks sunlight, reducing the efficiency of solar panels. When the sand settles, it covers the panels, requiring robots to clean them, which also need maintenance. Leaving the domes would always be dangerous. Mars has a very thin atmosphere, about 100 times thinner than Earth's, meaning there's 99% less air and a lot more objects from space make it to the ground without burning up. Because Mars' core is frozen, it lacks a magnetic shield, making cosmic and solar radiation constant threats. Each spacesuit would be equipped with sensors to detect critical levels of solar radiation and potential danger from space. Elon Musk proposed an intriguing idea to artificially create an atmosphere on Mars by detonating nuclear bombs over its poles to raise global temperatures. However, this plan wouldn't work because the amount of carbon dioxide, CO2, and other greenhouse gases on Mars is insufficient. Even if we could access all the CO2 in Mars' atmosphere, it wouldn't be enough to make a significant impact. To sustain liquid water on Mars' surface, atmospheric pressure would need to increase drastically. The current atmospheric pressure on Mars is about 6 millibars, whereas it would need to be around 2,500 millibars, over 150 times more CO2 than Mars currently has. Melting polar ice caps to release water vapor would fail without enough greenhouse gases, as the water vapor would just freeze again due to low temperatures. Additionally, the radiation from nuclear bombs would make Mars even more uninhabitable, especially near the poles. Mars' proximity to Earth is its only appealing feature, but is that enough to justify the immense investment of technology and resources for such a slim chance of success? What if there is a better world for our cosmic ambitions? Titan, a cold, icy moon orbiting Saturn, is even further away from Earth. Despite this distance, it could be a better candidate for human settlement. Unlike Mars, Titan already has an abundance of resources on its surface and underground, which could be collected, repurposed, and recycled. We've already built one space colony, the International Space Station, ISS, which is only about 250 miles from Earth. The ISS requires continuous resupply of resources, similar to a hypothetical Mars colony. However, Titan's resources could potentially reduce this dependency. The Cassini spacecraft took nearly 7 years to reach Saturn. With advancements in technology, it's possible that in about 50 years, we could transport a group of human colonists to the Saturn system in just around 2 years. Titan's thick atmosphere, mostly nitrogen, and surface liquids make it an intriguing candidate for future human exploration and potential colonization. In the middle of the vast, desolate expanse of Titan, where the average temperature hovers around -300 degrees Fahrenheit, a brave group of settlers dreams of building their future. Titan, one of Saturn's moons, is over 5 times further away from Earth than Mars. Embarking on a journey to Titan means leaving home and never coming back. However, Titan has a significant advantage over Mars, its atmosphere, which is about 50% thicker than Earth's. This thicker atmosphere makes terraforming the moon much more feasible. A dense atmosphere means it is easier to trigger a greenhouse effect to increase the temperature. Even a slight temperature increase of about 75 degrees Fahrenheit could potentially turn liquid methane into gas, setting off a chain reaction of transformative events. The liquid methane rain cycle would stop, ice would start melting, and the moon could eventually become covered with an ocean. However, this is a long-term projection and would take a considerable amount of time. Currently, the colony operates under a deadline, with finite resources of energy, food, oxygen, and water brought from Earth. Like on Mars, settlers on Titan need specialized heated suits and respirators, but at least they won't need to be pressurized. The atmospheric pressure on Titan is 50% higher than on Earth, which feels like being 50 feet underwater. On Mars, the atmospheric pressure is too low, and walking there without a pressure suit would be almost like being exposed to open space, causing the skin and muscles to swell, joints to become stiff, lungs to rupture, and bodily fluids, including blood, to boil. This is not a fate most would choose. Despite its hostile surface, Titan is a treasure trove of resources. One significant resource is hydrocarbons, including propylene, which on Earth is used to make plastics and resins. These materials become essential construction resources on Titan, used to create durable, lightweight structural elements for habitats, insulation materials, tools, and potentially even components for communication devices. The colony lives in eternal dusk. Even at the brightest part of the day, Titan is still shrouded in a hazy atmosphere, making navigation challenging. However, settlers may not require protection like domes to start establishing the first habitats. Although Titan has no magnetic field, it is shielded by Saturn's rotating magnetic field and spends roughly 95% of its time under the ringed planet's protection. As settlers discover the alien world of Titan, it starts to seem not so alien after all. There are dunes, rivers, lakes, seas, and although it happens very slowly, Titan even experiences seasonal changes once every 7 Earth years. Instead of water, the bodies of liquid on the moon's surface are filled with liquid methane and ethane. On Earth, natural gas is mostly made of methane, but there's so much of it on Titan that if there was any oxygen, the moon would erupt. However, the colony finds a perfect use for the abundance of methane. Since Titan is 880 million miles away from the Sun, solar energy generation is not feasible. However, just as we use lakes and seas to generate hydropower on Earth, the same can be done on Saturn's moon. Scientists think there's enough methane on Titan to produce power for tens of thousands of years. Methane also contributes to the formation of complex organic compounds. Aside from 5% methane and small amounts of carbon-rich compounds, Titan's atmosphere is mostly nitrogen. When these molecules face sunlight and high-energy particles in Saturn's magnetic field, they react with hydrogen and carbon, giving rise to complex organics. Meanwhile, oxygen production experiments are being conducted in controlled environments. Titan has an abundance of methane, and while the idea of introducing oxygen to Titan's atmosphere might sound like it would cause an explosive reaction, it won't cause the moon to explode. Oxygen itself isn't flammable. For an explosion or sustained fire, you need a combination of a fuel source, an oxidizer like oxygen, and an ignition source. Even if we were to introduce free oxygen to Titan's atmosphere, it would likely freeze before reacting with methane. Additionally, increasing the oxygen concentration would decrease the methane level, crucial for a reaction to take place under Earth-like temperatures, where at least 5% of methane in the air is needed. In isolated rooms with the right temperatures, settlers extract oxygen from water through a process called electrolysis. This is how breathable air is produced on the International Space Station, ISS, by splitting water into its two basic components, hydrogen and oxygen, by passing an electric current through it. Methane can still be used as a propellant. The moon's liquid methane and ethane lakes are like reservoirs held in the right conditions and waiting to be tapped. Pumping up liquid hydrocarbons from a lake with a simple hose will do the trick. To burn it, colonists need liquid oxygen, which they produce by melting the hard frozen water ice on Titan's surface. Reactors are used to heat this ice, and the resulting liquid oxygen and hydrogen are stored in external containers, taking advantage of Titan's frigid temperatures. Fortunately, Titan is full of water. Scientists are certain the moon contains a subsurface ocean where water isn't frozen and can be extracted for our purposes. In accordance with NASA's mission objectives, the moon's ocean is explored by a submarine. The first ever complex alien life might be hiding down there, potentially resembling the living organisms that reside at the ocean floor on our planet, where there's no light either. Once breathable air is secured, the colony starts cultivating plants. Titan's atmosphere, like Earth's, is full of nitrogen, a crucial chemical element that acts as a fertilizer for crops. Light takes approximately 80 minutes to travel from the Sun to Titan, and it's about 100 times fainter than on Earth. Enormous mirrors to focus more sunlight on Titan's surface won't work, not just because of this but also because the moon orbits Saturn instead of the Sun. The colony faces yet another challenge, figuring out a way to create a source of artificial sunlight. One idea the colony considers is making a glowing ball of molten tungsten and bringing its temperature to that of our Sun. Unlike most materials, tungsten remains a liquid at extremely high temperatures. One of its unique characteristics helps minimize the area of its surface, potentially allowing colony scientists to keep its shape round. If tungsten were a gas, it would simply disperse into space, but with a ball-like liquid shape, it can serve as a source of heat and light. To make this idea a reality, colonists have an abundance of working hours. One day on Titan lasts about 15 Earth days. While populating Titan is no easy task, compared to Mars, it's a more promising place for such an ambitious endeavor. However, Titan isn't the only moon open for colonization. There's also Europa, Enceladus, and Ganymede, each with its own potential. Thanks for watching.